So name of that theorem is variance of variance of a linear combination, variance of a linear combination of random variables. So now we are discussing the one of the important theorem. See, I told you to join at what time? 10 minutes already over, right? Variance of a linear combination of a random variable. So here first we go for the statement of that theorem, then we go for proof of that theorem, right? So statement, right? If x and y are, if x and y are two discrete random variables, two discrete random variables, then we have two statements regarding variance. One is variance of ax plus by equal to a square into variance of x plus b square into variance of y plus 2 times of covariance of x comma y. Then one more statement, that is variance of ax minus by, which is equal to a square into variance of x plus b square into variance of y minus 2 times of covariance between x and y, where a and b are any two real constant, where a and b are real constants. Right? So this was the theorem with this definition, with this statement, that is if x and y are any two discrete random variables, not only discrete, these are applicable for continuous also. In general, you can take if x and y are any two random variables, then variance of ax plus by equal to a square into variance of x plus b square into variance of y plus 2 times of covariance, 2 times of ab into covariance of xy. Similarly, suppose we have here minus, this will be equivalent to this equation, right? So now we are going to prove this. We are going to prove. So proof now who joined? Right, proof. So here, let us consider for first one. Let us consider whatever you define, that is ax plus b. We define one new random variables, that is u equal to ax plus by, right? So then what is our variance of u? We have the formula, right? What we have the formula? Variance of x equal to expected value of x minus expected value of x whole square. Instead of x, what we have here? U. So here expected value of u minus expected value of u whole square, right? Now instead of here x, we have u, where u is ax plus by, right? Now, we required expected value of u. So what to consider u means ax plus by. So then expected value of u equal to expected value of ax plus by. So this is equal to, when you apply the expectation inside, this is a into expected value of x plus b into expected value of y. So right. So here we have expected value of u equal to this. Now we'll insert this equation here. I mean variance of u equal to expected value of u as it is, right? Okay, not u as it is. Just to take u equal to what we consider here, ax plus by. So u equal to ax plus by minus expected value of u is this one. This will be minus times of a into expected value of x plus b into expected value of y whole square, right? So variance of u equal to expected value of ax plus by as it is. So here minus a into expected value of x minus b into expected value of y whole square, right? So here uh, expected value of ax minus a into expected value of x plus by here, then minus b into expected value of y, we'll consider its whole square. This is equal to expected value of, here I will take a common, a into x minus expected value of x, we take common, plus b into y minus expected value of y, we'll take b common here, then this will be remaining equation, right? Then then here what we have, you treat this entire term as a and this you treat entire term as b. So it is a plus b whole square formula. So apply a square, a plus b whole square, that is expected value of, first is a square, that is a square x minus expected value of x whole square plus b square. B square means this, you treat this entire term as a and this entire term as b. So a square means this square plus b square means this square, that is b square into y minus expected value of y whole square plus 2 times of ab. So 2 times of a means what? A into x minus expected value of x into b means b into y minus expected value of y, right? So this expectation outside is it. Now we'll take this expectation inside, right? So this will be a square expected value of x minus expected value of x whole square, right? Plus b square expected value of y minus expected value of y whole square plus 2 times of ab as it is, expected value of x minus expected value of x, then y minus expected value of y, right? So here a square as it is, this is nothing but what? Variance of x definition exists or not? So this is nothing but variance of x plus b square as it is, variance of y plus 2ab is there, plus 2ab expected value of x minus expected value of x into y minus expected value of y is nothing but our covariance of x comma y. Sorry, right? So hence whatever we consider, that is Freudian. Clear? Next we have second half of the proof, that is, let us consider v equal to ax minus by, right? So now variance of v equal to variance of v minus expected value of v whole square. This is what our basic formula. So equal to equal to variance of v means what? We have ax minus by minus expected value of v, that is expected value of ax minus by whole square. So first we'll find out this value. That is expected value of ax minus by equal to a into expected value of x minus b into expected value of y. So this is equal to variance of ax minus by minus this entire term, that is expected value of x plus b into expected value of y whole square. Y here means here already we have minus, so minus will multiply here inside. So minus a into expected value of x minus of minus, that is plus b into expected value of y. This is equal to same procedure. Here we take a common. So suppose we take a common, this will be x minus expected value of x. Then here I suppose I take we'll take here minus b common, because we are minus by, here also plus b expected of y. So I will take minus b. What are the remaining thing? Y minus expected value of y whole square, right? So now here somewhere we miss. Wait. It is not variance, it is expected. Na? This is what expected value. Okay, now same. You treat this as a, you treat this as b, then a minus b whole square formula, that is a square. A square means a square x minus expect x minus expected value of x whole square plus b square y minus expected value of y square minus 2 times of ab. A means what here? A 2 times of a means what? A into expected value of x minus expected value of x into b y minus expected value of y. So whole expectation is there, this expectation, which is equal to expected value of a square x minus expected value of x whole square plus b square y minus expected value of y whole square minus 2 here, a 2a is there. From b here I will take, so b 2ab. Oh shit. 2ab. Then what we have here? X minus expected value of x, y minus expected value of y. So here whole expectation. Now when we imply this, when we apply this expectation inside, so a square into expected value of x minus expected value of x whole square plus b square expected value of y minus expected value of y whole square minus 2ab expected value of x minus expected value of x into y minus expected value of y. A square, this is nothing but our variance of x definition. B square, this is equivalent to variance of y minus 2ab. So this is equivalent to covariance between x and y, right? So these are all the two different proofs of that theorem. So I hope it's clear. Now we go for some remarks. Remarks. So first one, for a particular value, when a equal to b equal to 1, then see here already what we have, variance of ax plus by equal to a square into variance of x plus b square into variance of y plus 2 times of covariance between x and y, right? When you put a equal to 1, b equal to 1, this is nothing but variance of a is 1, right? So this is nothing but variance of x plus y, a square, 1 square, 1 square 1, so remaining is variance of x plus b square, b is 1, so its square is also 1, so variance of y plus 2 times of a into b, sorry here 2ab, then covariance of x, so 2 times of a into b, that is 2 into 1 into 1, that is 2 only, so covariance of x comma y. Clear? So according to that, it may changes. Say for example, for a particular when a equal to 1 and b equal to minus 1. So now variance of ax plus by. A is 1, 1 square, 1 into variance of x, that is variance of x, plus 1. Why? Because b is minus 1, its square is 1. Next, here, minus 2 AB, so it is 2 only, covariance of x comma y. Why it is minus means here 2 into a is 1, b is minus 1, so that will be 2 into 1 into minus 1, that will be minus 2 covariance of xy, right? So here according to this it may changes. The next remark is, if x and y are independent, right? When x and y are independent, right? So whenever x and y are independent, there is no correlation. When x and y are dependent, that is covariance between x and y is 0. Then variance of ax plus by equal to a square into variance of x plus b square into variance of y plus 2 times of ab covariance of x comma y. If x and y are independent, so this term will be 0. If it is, this term is 0, entire this term is 0. So therefore variance of ax plus by equal to a square into variance of x plus b square into variance of y. That's it, right? So there is no covariance term, so entire this term will be 0. For instance, put a equal to 1 and b equal to 1. If x and y are independent, then what about a variance of x plus y? This is nothing but variance of x plus variance of y. Clear? But variance of x minus y is also equal to same variance of x plus variance of y, right? So variance of x plus y and variance of x minus y are same, that is equal to variance of x plus variance of y, if and only if x and y are independent, right? So this is what the third remark about the properties of variance or some additional knowledge about variance. Then we have one more, that is fourth one, when x1, x2 and so on up to xn are independent, are independent random variables, then variance of a1x1 plus a2x2 plus a3x3 plus and so on up to plus anxn is equal to 1 square into variance of x1 plus a2 square into variance of x2 plus and so on up to an square into variance of xn, right? So here a1, a2, a3, so on up to an are any n real constants, right? So it is applicable only when variance of, sorry, when x1, x2, so on up to xn are independent, right? If these are not independent, this theorem fails. If these are independent, okay, this theorem will be applied, right? Theorem means this is a remark. Clear? Next, one more remark we have. That is, if x and y are independent random variables, you know how to find out the independency, right? That is the joint probability density. Say for example, f of xy is equal to f of x into f of y. Then we say independent. Otherwise, we can't say. Likewise, if x and y are independent random variables, if x and y are independent random variables with expected value of x is equal to 0 and expected value of y is equal to 0, then variance of xy, variance of x into y is given by, so variance of x into variance of y, right? Variance of x into variance of y. But here what they given? Okay, this is what the given remark. So one more time I will recapitulate this remark. If x and y are independent random variables, again same here also independent, right? If these are dependent, this one won't work. This one, this variance of xy is equal to variance of x into variance of y won't work if they are dependent. If they are independent, then only it works, right? So these are what some few properties regarding variance of bivariate case. Now we have some examples. Two examples we will solve. Here, a good example, this one. If variance of x plus y is given, that is 3, and the given variance of x minus y, that is 1. Then they given expected value of x, that is also 1, and expected value of y they given, that is 2. Then what they are asking, then what is expected value of xy? What is expected value of xy? So here, how to just think how to solve such examples. See, this is some special kind of example, right? What they given that first you need to write what they given that what are they given, variance of x plus y is given, that is 3. Then they given variance of x minus y, that is 1. They also given expected value of x, that is 1, and they given expected value of y, that is 2, right? Then what we required, our aim, our job is to find out expected value of xy, right? So to find out expected value of xy, what our in our regular classes or our regular theory we studied, expected value of xy, if it is discrete, we have double summation xy into f of x comma y. Expected value of xy is nothing but, if it is continuous case, double integration xy f of x comma y dx dy over the limits y and x. Here x equal to 0 to infinity and y equal to 0 to infinity. Right. So here uh, we can apply these two formulae, right? But how to find out expected value of xy? See, there is no distribution is given. There is no distribution, right? The distribution is not yet given. So then how to find out? But they given one information, that is variance of x plus y and variance of x minus y. Clear? So just you need to consider, just wait. Right? You need to consider variance of x formula. So sorry, variance of x plus y. Variance of x plus y equal to, what is the formula? Variance of x plus variance of y plus 2 times of covariance of x comma y. Then variance of x minus y, because variance of x plus y is given, variance of x minus y is also given. This is variance of x plus variance of y minus 2 times of covariance between x comma y. Right? So consider this is as a equation 1. Consider this as a equation 2. Right? So then subtract equation 1 from equation 2. That is nothing but equation 1 minus equation 2. Right? So that is nothing but what we have in equation 1. Variance of x plus y, that is variance of x plus variance of y plus 2 times of covariance between x comma y. This is equation 1 minus equation 2, that is variance of x plus variance of y, but here already minus is outside, so it is also minus of variance of y. Then minus of minus plus 2 times of covariance between x comma y, which is given 3 minus 1. Why it is 3 minus 1? See here, variance of x plus y equal to 3, variance of x minus y is 1. Right now, plus variance of x minus variance of x plus variance of y minus variance of y get cancelled. Now what we have? We have 2 times of covariance of x comma y plus 2 times of covariance of x comma y. This is 2. Right? Clear or not? So 2, this 2 times of covariance of xy plus this 2 times of covariance of xy, that is total 4 times of covariance of x comma y equal to 2. So covariance of x comma y equal to 2 divided by 4, that is equal to 1 by 2. So here we obtain covariance, right? And we know that. So what do we know? Covariance formula. We know that expected value of xy minus expected value of x into expected value of y, which is equal to covariance of x comma y. So this is our target. We are going to find out expected value of x into y minus expected value of x that is given in the question, that is 1, and expected value of y is also given, that is 2. So 1 into 2, which is equal to covariance. Covariance is already we found, that is also 1 by 2 here. Covariance is found here. So this is also 1 by 2. Then expected value of x comma expected value of xy equal to 1 into what we have here, 1 into 2, that is 2. Sorry, wait. Expected value of xy minus 2 equal to 1 by 2. Expected value of xy equal to 1 by 2 plus 2, right? So expected value of xy equal to 5 by 2, right? So in this way we need to obtain. So here x by y equal to, xy equal to 5 by 2 is the right answer. So how we solved, I think it's clear, right? With the help of variance of x plus y as well as variance of x minus y and covariance between x comma y. Using these three formulae, we get the value of expected value of xy. So I hope it's clear. We'll move to the next example. Let x and y are random variables with variance of x is given, that is 4. Then they given variance of y, that is 9. Variance of x is 4 and variance of y is 9. And they given one more information, and variance of x minus y, which is equal to 16 they given. Then they are asking what is covariance between x comma y, right? Okay, in our knowledge, to find out covariance, what are the formula we are using? Covariance of x equal to expected value of xy minus expected value of x into expected value of y. But here what we have the practical difficulty, there is no expected value. There is no value in terms of expectation. But what they given? They given one information, that is variance of x minus y, right? So depending upon this information, we can just solve this example, right? Solution. Given that, first we need to write down, given that, right? So what they given? Variance of x they given, variance of x equal to 4. Then they given variance of y equal to 9. Then they given variance of x minus y. This is important, equal to 9. So write down the formula, variance of x minus y, variance of x plus variance of y, minus is there, so minus 2 times of AB. AB means here 1 9 minus 1, so it is minus 2 only. Minus 2 times of covariance between x comma y. So all the informations are given. X minus y, here they given x minus y, what they given? Oh, sorry, it is 16. Huh? So x minus y, this is 16. Equal to variance of x. Variance of x they given, that is 4, plus variance of y is given, that is 9. So 2 times of covariance of x comma y. Solve the simultaneous equation, you will get 16 equal to, this is 13 minus 2 times of covariance x comma y. So now 2 times of covariance x comma y, I will take this side. So here what we have? Here we have 13 and 16 will be this side. So 2 times of covariance between x and y is equal to minus 3. So covariance between x comma y is equal to minus 3 divided by 2. Right? So in this way, we need to solve such examples. So I hope this example is also clear. Now we'll go for one more example. Example number 3 in this bivariate variance concept. So let x and y independent random variables each with the density, each with density function, that is f of x equal to 1 divided by 2 theta minus theta less than x less than theta. If variance of x comma y they given, that is 64 by 9, then what is the value of theta? Then what is the value of theta? So here we are going to find out the value of the theta by the given information. All right. So what are they given here? Solution. They given f of x. This is 1 by 2 theta minus theta less than x less than theta. They given what they given? Random variable each, right? Each with the density function. It means that f of y is also have the same 1 minus 2 theta, theta less than theta, but here range is y because we are taking in terms of y. Now, what we are going to find out? We are going to find out the value of theta. Here we will get the value of theta means, suppose we take variance. But before that, first we need to find out expectation. So expectation value of x. This is integration minus theta to theta x, f of x is 1 divided by 2 theta dx. So 1 divided by 2 theta integration minus infinity to infinity x dx. Expected value of x equal to 1 divided by 2 theta x square by 2 minus theta into theta. This is 1 divided by 4 theta, 1 divided by 4 x square, that is theta square minus theta. So expected value of x equal to, when we take theta common here, theta into theta minus 1 divided by 4 theta, this will be theta minus 1 by 4, right? Hey, wait. Somewhere we did wrong here. Just wait. See here, it is minus theta. So 1 divided by 4 theta common, x square means theta square minus theta square, that is also theta square, right? Here we get theta square. Then expectation value of x equal to 1 divided by 4 theta into 0. So this will be 0. Next, here we go for expected value of y. This is nothing but minus theta to theta y f of y dy. So this is nothing but minus theta to theta y. F of y is 1 divided by 2 theta into dy. So expected value of y equal to 1 divided by 2 theta outside. Then we have y square by 2 theta 2 minus theta. This is nothing but 1 divided by 4 theta, again theta square minus theta square. So expectation value of y is also 0, as well as expectation value of x is also 0, right? So what they given the information, independent random variables, right? So if x and y are independent, with expectation of x is also 0 we got, and expectation of y is also 0 we got. So with expected value of x equal to expected value of y equal to 0, then what I given the formula, variance of xy, variance of x into variance of y, which formula means this one. See here. Here by remark number 5, if x and y are independent random variables, then expected value of x is 0, expected value of y is also 0, then only this is approved. I mean, this is proved, otherwise it is not. So here variance of xy equal to variance of x into variance of y, right? So come back to this our example. So variance of x and variance of y we need to find out, right? So now, so here variance of x equal to minus theta to theta. Sorry, before this I need to write one. See, variance of x formula is variance of x square minus variance of x whole square. So here we got this 0. So variance of x is equal to expected value of x square only, because this value is 0. This is equal to minus theta to theta x square f of x dx, right? So variance of x equal to expected value of x square equal to x square minus theta to theta. F of x is what they given f of x? This is 1 by 2 theta dx. This is equal to 1 divided by 2 theta outside. X square derivation is x cube by 3 minus theta to theta. So this is variance of x equal to 1 divided by 2 theta into 3. So it will be 6. 1 divided by 6 theta. 1 divided by 6 theta. Then what we have? X cube. X cube means theta cube minus of minus theta cube. This is nothing but theta cube plus theta cube divided by 6 theta. Right? So here variance of x is equal to 2 theta cube by 6 theta. This is nothing but 1 square 1 3 theta square by 3. Right? Similarly, we need to find variance of y also, because we need variance of y also. So variance of y is equal to sorry, expected value of y square, expected value of y whole square. So variance of y equal to expected value of y square only, because this term is 0. So now integration minus theta to theta y f of y dy. Sorry, y square here, because we need expected value of y square. So minus theta to theta y square 1 divided by 2 theta dy. So 1 divided by 2 theta integration minus theta to theta y square dy. So this is nothing but 1 divided by 2 theta y cube by 3 minus theta to theta. So which is equal to 1 divided by 6 theta y cube. Y cube is theta cube minus of minus theta cube. 1 divided by 6 theta cube minus of minus is again here 3 times is there odd number. So it will be minus of minus is plus 3 cube. So 2 theta cube divided by 6 theta, same 1 3 is the whole. So theta square by 3, right? So now variance of xy is given by variance of x into variance of y. So variance of xy, x into y here, equal to variance of x. What we got? Variance of x. Variance of x we got that is also theta square by 3. And here variance of y is also theta square by 3, right? Is it clear? So this is equal to theta power 4 divided by 9. But what they given variance of xy? They given variance of xy. So if you observe clearly, variance of xy is given as 64 by 9, right? Is it clear? So in previous slide, what we got? Variance of xy equal to theta power 4 by 9. So variance of xy equal to theta power 4 by, what you get? Theta power 4 by 9. But this value is given in the question, that is variance of xy, that is equal to 64 by 9 theta power 4 by 9. So this 9 get cancelled. So what we have? 64 equal to theta power 4, right? 64 for theta power 4. Now 64 whole power 1 by 4 equal to theta. This is nothing but 64 here 1 by 4 equal to theta. So this is nothing but theta equal to 2 into root 2, or this is equal to square root cube root. This is nothing but root 8 is there here, right? So this is what 2 into root 2. In this way, we need to solve the several examples regarding this concept, right?